Yeah, thank you for the introduction. I know that my name might be hard to pronounce. So yeah, my name is Radion. Let me reiterate. Yeah, today I will share how we attempted to improve our fraud performance in the company. So I work in Anna Money I've been working for past 4 years now. And yeah, so basically for those who are not aware, this is essentially a banking application for businesses. So imagine you are a sole trader or a limited company and you need a banking account. So we actually can provide you with one, and we also offer some additional services to simplify your life, like accounting, taxes, all of it. And as a financial institution, we have to have some control in place, right? So there is a lot of stuff that goes on the back end in our company. So, and I've been working in this FinCrime prevention unit as a data scientist. So my role is essentially to develop these scoring models of customers to prevent our customers from committing fraud. So when it comes to fraud, we can have two separate directions that should be tackled in different ways. The first one is protecting our customers from becoming victims of fraud. And the second direction is actually from stopping them to commit fraud. And yeah, so I'll be focusing on the second direction in this talk. And yeah, here are a few examples of fraudulent activity that we saw in the company. So we had a customer who advertised themselves as a clean company, but in fact, after a while, we started receiving reports that they introduced themselves as a investment company, and they tricked others into sending investor money, and they just disappeared afterwards. So then there is this builder that also can disappear after taking the down payment for some works and actually never providing services. So all of it we can call fraud. And there was a lot of motivation for the UK companies to start working on improving the fraud controls. For those who are in the industry might be aware of the legislation that became active the last October, which essentially motivates companies to develop their controls because they need to reimburse half of the losses caused to customers. So yeah, in our system, okay, we are very motivated to develop these fraud controls. How do we do this? So we have a lot of data about our customer. We have information about transactional activity. We have information from our application, its usage, and so on. We also have their answers about their business and the documents that they provided to us, and many more things. So yeah, an obvious solution is to develop a fraud scoring model. Okay, this is one part of the picture. Another part is that we need to implement controls. Like developing a fraud scoring model is not enough. We need to integrate it in our system. But nevertheless, this is quite a difficult topic on its own, I would say. But yeah, today we'll be talking solely about developing the model. Okay, so to develop a model, we need to introduce some features to it, right? We need to make our decisions based on the information from our customer. But what input should we use for, like, how do we engineer the features? How do we understand that features are actually useful? Because, like, it doesn't work as a magic. Like, it's not a Kaggle dataset, right? When you're provided with something and you just feed it to your machine learning model and stay happy. You need to actually engineer features, and often it can be a lot of work. So we need to. So the simplest approach is actually to talk with analysts and experts inside of the company or maybe outside of the company to brainstorm some ideas of what can actually be helpful to detect fraud that we're interested in. So yeah, that's what we did at the initial stage. So we ended up with a spreadsheet, quite a lengthy spreadsheet with a huge number of features. And it was quite overwhelming, I would say, because we need to understand what are the most impactful features, how do we prioritize the backlog. It was quite difficult to do, but we had to resort, to subjective estimates. And humans also have biases, because they believe that this feature should be really great at detecting fraud, but in the end of the day, it had like almost no signal. That's what I saw several times at least. And another problem is that humans also are black boxes in a way, right? You need to talk with them to extract the information, but sometimes it can be difficult to extract the knowledge from their heads. So this is another problem. So, but nevertheless, we ended up prioritizing this hugely. Somehow we selected features that had high subjective impact, but were really easy to implement, and it became a good baseline for us. Okay, then what can we do next? How do we discover more features? How do we improve our fraud detection? So another approach is that we need to actually look into the data, right? And I know I'm a data scientist, and I know that my colleagues and me also, we're very reluctant to actually do this routine work, looking into the data, understanding how it works, where the signal could be, how we should engineer the features, all of it. But that is something that we had to do. And the problem was that, okay, we have a customer's profile. There is a lot of data, and it's actually to properly review a customer, it takes around 1 hour to review only one customer to understand what his business is about, to understand all the documents that he provided, all his transaction histories, and so on. So it's very costly and time consuming. But nevertheless, I managed to review a few dozens of accounts. I compiled some backlog. It helped me, it gave me some idea on how to prioritize features a little bit better, what to focus our attention on. But the problem with this approach that, naturally, the sample size of customers that you reviewed is very small, because it's very difficult to do it in a fast and accurate manner. So, and because of it, it's quite easy to miss some patterns and features. Yeah, so can we do something else? So this is what we, this is the gist of the approach that I will talk about. And essentially what we attempted to do, we asked ourselves, can we speed up or automate account review such that we could extract more features from these summaries? So what we attempted to do, we essentially gathered all the data, and we generated, using these LLMs, we generated summaries for each section of customer profile. And at this point, we had quite a sufficiently big sample size to run some experiments on it. So we encoded the text with n-grams, ran a simple scorer on top of it to understand where the signal, in what sections of the customer's profile have signal, how do they compare it to each other, and so on. So in the end of the day, it helped us to derive some backlog and prioritize it a little bit better. Okay, let's dive into the approach. So the first step is generating the summaries of customer profile using LLMs. So there are a few prerequisites that we need. We need to have to use it actually. So first of all, we have a standard operating procedure for kind reviews. This is SOP. This is maybe a fancy word, but essentially this is the algorithm that you give to your analysts and say, okay, you need to follow this procedure, and if you follow it, essentially we expect that you won't miss anything important about the profile, and it also makes the review procedures standardized. Another prerequisite for the approach is that you need to have a lot of information, probably too much information for you to review. And yeah, we also knew that the LLMs are getting quite capable, so why not try them for this? And yeah, so what we assumed is that the SOP has to be comprehensive enough. So if we essentially this SOP becomes a prompt for an LLM in a way. So if we prompt an LLM to follow this SOP, it has to be comprehensive enough, such that we don't miss any important signal because it is not mentioned. Because imagine if the SOP is not comprehensive and it misses out a huge fraction of customer profile, we will naturally lose the signal in the summary, right? And another assumption is that these language models are capable enough and we don't lose any important information by applying them. So yeah, what we did, we essentially gathered all the information that we had from our customer profile, grouped it by sections, and then prompted LLMs to following this SOP to generate summaries for each section. Yeah, it might be, well, it sounds very straightforward, but in reality, it wasn't that simple. There were some peculiarities to how to do it properly. So yeah, these are the building blocks of the overall summary. So we had the information about company, very high-level information, maybe from company's house, probably what they provided to us. Then we had documents that customers provided to us. Importantly, there can be various kinds of documents that need different treatment, I would say. And because of it, we generated summary for each document individually and then combine it into overall document summary. Then we also have this online presence section. And the interesting part is the transaction analysis. So in order to make a conclusion, make a decision whether to properly review transactions, you need to understand the customer's business, right? So that's why there are these arrows coming from company information, from documents sections to the transaction summary, because we need actually to compare transactions with the customer's business. So yeah, we do analysis of top counterparties, and then we generate the overall transaction summary. So we also have some additional blocks that's related to our interaction history with the customer, the information about his related accounts. By related accounts, I mean, imagine you have a customer, and then essentially an entity that you observe is a company, but there can be a related company with the same director, or there can be a company related by the same phone number, and there can be various relations that you actually want to consider to make a comprehensive review. So yeah, those are small building blocks that come down to that become essentially the full summary. So yeah, this is an example of the summary. I essentially stripped off it from any information from sections, just to give you an idea how it looks like. So yeah, there is this few sentence high-level overview of the customer business. There are some concerns that we highlighted from my customers' accounts. Then we have these sections about company, line visibility, documents, related accounts, transaction summary, all of it, everything that I mentioned before. So yeah, okay, so we generated these summaries for a customer. So essentially, it replicated the manual review procedure that I had to do. The question is, how do we understand where we can extract, where the signal is buried inside of these piles of text? So it's quite, the answer is pretty straightforward. And yeah, let's run a fraud scoring model on top of it. And for this particular task, I chose the simplest approach that I could think of, because I had some backup plan. Maybe I could try something fancy like transformers with some attention visualization, all of it. But yeah, initially I tried TF-IDF with n-grams and logistic regression. So yeah, the fraud scoring task is framed as a binary classification task. We had labels. Yeah, so that's why I just could take this simple pipeline and run on top of this text. So there were few things that I needed to understand, where how sections of the summary compare to each other. because it would help us to understand like where we should prioritize, where we should focus our attention on to develop these features. And yeah, then within each section, we needed to understand which n-grams or the potential features actually have the signal. So yeah, I'm not worried to post here like metrics explicitly, just because the absolute values are not that important here. The important part here is that the relative, we need to pay attention to relative performance of the sections. So yeah, we have this table with like each section name, then we have average precision metric. So average precision, we can think, well, it is kind of similar to area under precision recall curve. So this is a metric that gives you an idea how you perform on your target class of interest. So yeah, importantly, the overall profile like had the most signal, which is not surprising, but that was a way for us to validate it. Yeah, it's kind of reasonable that it has the top performance. And then what we saw next is that yeah, we have this transaction summary, which is not surprising, but it has like this is the major contributor to the signal to the overall summary. Another interesting thing is that we actually had a model in production, which is essentially based on the same information that the related account section has. And the tabular model, when it's built like in a proper way, it has these numerical features, like not based on n-grams. It had higher performance than the section based on essentially the same raw information. So this is a good indicator for us that if we decide to actually develop features, we might achieve better results. So this is an example. I just took this top income counterparty section, and yeah, this is how it looked like when I attempted to review it. So I limited the size of vocabulary to first of all, to reduce the noise, second of all, to save some time on reviewing these n-grams. And yeah, the approach is very basic, right? There is no rocket science here. So I just looked into the n-grams, I compared it, I checked their logistic regression coefficients. So the lower coefficient is, it means that it's likely to be a de-risking factor. The higher coefficient is means that, yeah, it's a factor increasing risk of a customer. So what I did, yeah, and of course, like you need to regularize it a little bit. So again, to reduce noise, to get rid of, to have this nice tail of n-grams that have small weight and you will never review them. Yeah, so essentially the approach was simple. I just looked up the n-grams in text, and it gave me an idea of what the feature could be like. And this is how, so yeah, I reviewed the n-grams for all major sections. And yeah, I compiled another backlog for us. And what was interesting is that some of the features were not that obvious. Like I'm showing this one, but I'm not going to deploy it. It just, we managed to extend our knowledge. Some of the features that we found, like actually majority of them, overlapped with what we knew already. And this is, I take it as a good sign. That means that the approach works, right? So we're not receiving here contradictory knowledge to what we had. But we also compiled, I found quite a few interesting ones. So this is a funny feature. So customers who receive refunds from Anna, this from us, they are less risky. So the intuition is that actually they are not afraid to be exposed to us. So they do, because they complain, right? They write a complaint. Something went wrong for them, and yeah, they are less likely to be fraudsters. But yeah, this is a rare feature, and yeah. Yeah, so the another outcome was that we actually saved time on this feature discovery. We have these nice summaries that we can resort to if we want to clarify something, when we want to maybe. So we have this approach like ready for new like when a shift happens in fraud, we can always use this approach again to discover new features. And yeah, one of the features that we discovered from it, like actually helped only one of them helped us to actually boost the fraudster recall by like relative 20%, whatever that means. Whatever that means. It's always useful to have this hands-on experience with your data, especially when it's like when it will shrink to a more manageable amount of information. So yeah, I got some better ideas on how to engineer some of the features. Clearly, we managed to prioritize our backlog because, like, we know that okay, here we have more signal in this section. Probably we should be focusing our attention there. All of this, may sound very intuitive to those who are working in the industry for a while. But when you start actually solving a new task, sometimes you lack in this intuition, and sometimes, like, you can be led to a completely wrong direction, not a very productive direction on, like, engineering features on something that is not really fruitful when it comes to the impact. Another outcome was that, yeah, we also managed to adjust our procedure that agents used, because some of the sections, like, the procedure was written by a human and like by one of our like analysts. It doesn't really matter. So it's quite difficult to be very explicit sometimes. So like by definition, the procedure had to be vague occasionally. So for example, there was this section saying that decide if transactions align with the nature of business. And like, this is a correct statement, right? But it's quite vague. And it created some space for creativity, I would say, for other analysts. So like by looking into the actual data, by understanding what exactly can bring signal, can improve the signal, we managed to clarify these sections a little bit. Also, we managed to extend the list of red flags that we had in our accounts, our procedure to analyze. And by actually implementing these red flags as features, we also simplify the work of our analysts, because they don't need to calculate them with their head, right? They just look into calculated values that we developed. And yeah, so you might ask, okay, guys, you spend so much time on generating this account summary only for feature discovery. There might be something that there must be something that you could also extract on top of it. So yeah, there are other use cases for the account summary. It's just they're more tricky. So they require quite considerate. You need to be very considerate when decide to use them elsewhere. So there are a few things, like for example, you're saying, okay, we essentially automated the account review procedure. Can we use it to speed up the work of our analysts? And yes, you can. It just the trick is that you need to develop trust in the generated summaries, because like you're using LLMs that may not be perfect like all the time. They may make mistakes. They may hallucinate. And this is the area where we need to be really confident that something that we use in production is really confirmed by extensive evaluation, that it is trusted by our analyst and by the product team itself. Oops, I need to disable it, sorry. Yeah, I use it to because sometimes I'm too focused in the work, and I need some time some reminders to distract myself. So it's so what we observed is that our analysts tend to double check the information that they had in these account summaries. Actually, I spoke with colleagues like working in other companies on the European market, and they attempted a very similar approach, and their observation was quite different. They told me that when they used this account summary to speed up work of agents, like it was called differently, but essentially it was the same. So they observed that actually their analysts didn't challenge the summary that was generated. They just tend to believe it. So it is quite difficult to implement it into process when you need to interact with humans, because you have this extended period of learning. You need to make sure that you align with each other on expectations on how to use it in processes. Another use case was like, it might be, you might have thought of it already when I was presenting this feature discovery stuff. So can we use this generated LLM summary as a text feature and just use it like straightforward, just use it straight in the model? So yeah, we also need to answer a few questions before doing it. So can we afford to actually run the summaries in production for all our customer base? Can we do it like regularly? Or maybe we need to optimize it. We need to select a fraction of customers that we're interested in more, maybe something else. Are we happy with the processing delay? Because like to generate a summary, you need to spend like a minute or two, because as you remember from that execution schema that I showed you, we have quite a few blocks, and for each block we generate its summary, then we feed it together. So not everything can be parallelized, so it's quite time-consuming, I would say. So yeah, it's if your system like is happy with having this processing delay, it can be fine. And also another question is that are we happy that the runs, like the summary that was generated on the same source data, or if the source data changes slightly, may not be consistent? Because we are working with LLMs, they're not deterministic, and yeah, it can cause a drift in production if you're not really careful. So you need to think about it. And yeah, so I think, like, having asked this question to myself, I decided, okay, probably we need to actually decompose the summary into features that we think are more promising. And because once we decompose them, we can perform proper engineering, proper evaluation of these features, even if they're generated by an LLM. Yeah, I think that's it. Thank you.